In this video, we will continue to talk about pointer, and we will see how we're using the const keyword associated with the pointer. In C++, we can give enough privilege for the programmer. And a lot of time we use the const keyword to control how much the programmer or the variable can be accessed. So we see how we will do that. So the first thing like we learned, when we declare a pointer to a variable, your pointer can refer to the variable. They can access by the reference. Then if you want to modify the value of the variable the pointer refers to, we can using the pointer to update the value as well. For example, if I have an int variable we call value, I assign the value equal to 22, for example. Then I declare another int pointer. This PTR will refer to the memory location of the values. So that's why the PTR will refer to the same location where the value's memory address is. Then using the dereference symbol. So this asterisk associated with the pointer, they can update the value. So after you reassign the PTR equal to 15, actually they will update the value. They will update this 15 to the value variable. So when you see out the value variable, they will display 15. So this one actually we already see that in the chapter 9 example. And also I add chapter 3 example -1. So we will play with that to see how it's going. So this one actually is regular how we declare a pointer to a variable. So that's why here let's open your example -1. So this one actually I just copy over from the example 3. So then we will see here I have x equal to 25. So then I can declare a PTR refer to this pointer refer to where the x is. I can just declare this pointer and right away assign the location for the x. So then if I want to try to display the value for x, or we do the asterisk PTR, what number will display? Say they both will display 25. So then just like we'll say, we can reassign the new value through the PTR. So even we assign 100 through the PTR, but they will update the value from x. Then you can display again the x value and the PTR dereference value. So that's why here let's run the program. So we will see originally the value is 25, but afterward they will become 100. So that's regularly how we're using the pointer to refer to a variable. But sometimes we allow the pointer to refer to this variable, right? So the pointer can refer to the variable. However, we don't want this PTR can update the variable value. So on the other hand, in C++, we call that the read-only pointer. If you allow a pointer to refer to a variable, however, you don't want this pointer can be able to update the variable they refer to, we will declare a read-only pointer to a constant data. So here we say the constant data is when we have a pointer. For example, here I'm using the double pointer rate. So this double pointer is how we define. So this rate pointer will refer to a double value. But if I want this rate double value can only read from where they refer to, but not updated that. So then we add the constant keyword on the data type. So this one is we call a pointer refer to a constant variable. But this constant variable actually is not the variable itself is constant. Actually, that means through the pointer, they can only read only. So the value cannot be changed through the rate pointer. Let me show you how that means. So that's the same thing earlier, our example. We have a value int value variable. We assign the value equal to 22. So I allow a pointer to refer to this value variable. But I don't want the program can through the PTR to update the value variable. So what we do is when we declare the pointer, so this pointer data type needs to be the same as the variable we refer to. So then before the data type, we add the constant keyword. So this constant keyword, what happened is, right, we do have a value variable. Okay, so this value variable is 22, right? So remember, you see value actually means the location for this memory address. So then, right, then I declare a pointer called PTR. So this PTR will do what? Right, they will refer to the location where the value is. After we have this pointer to refer to the values, right? But now when you try to access this pointer to assign to the value variable, but when we have this pointer, actually we add the const keyword to the data type. Actually, this const keyword happen in where? In the arrow here. So that means when you through the PTR, you are constantly referenced to the variable value. So then when compiler in C++ compiler, they know this arrow is using the constant reference. So they make this PTR, right? I can using the dereference to see out the PTR. Okay, so we see here. So when I do the dereference, the PTR, right, I can still display the value. So of course, you will see the 22 will be displayed. But then if I try to using this PTR to reassign the value, then you see here I cross out because they will have the compiling error. So we will check with IDE later. So that's why here is we told when you're using the const keyword is a pointer to refer to a constant variable. They actually is a read-only pointer. So this constant keyword actually is associated with the data type. That's how the pointer will refer to the variable. So then through the pointer, unfortunately, because when you try to update the data here, right? So compiler see this one is const pointer. So that's why they don't allow them to update the value. So that's why you cannot update to 15. So the only way you want to update this location to 15, we only can go through the original variable. So that's what we call the read-only pointer. So I want you to check it with the IDE. So that's why now we go back to our example 3.1. So now here you will see this one is our pointer, right? Okay, so let me add another pointer. So this pointer actually is, we say, the read-only pointer. So then I call this one is CPTR. So the same thing that's referred to X. So now here, you see, after you refer to X, right? Right, so then I can try to display. So when I want to display the value, right, I can still display. So here, maybe we just change instead to using the PTR only. Let's add one more. Okay, so we can display the value using the CPTR as well, because I can read the value through the CPTR. So can I display they are still 25? So then you can see here that's wrong first. So I want to see they can refer to the value. So that's why you can see we have 325 display. even here I have a read-only pointer constantly refer to the x. So I can display the value. So I can access the x value through the pointer cptr to display. But that's because I only want to display. So now if I want to using the cptr to assign the value to 200, that means I want the x to be 200, right? So then we see what happened. So when I run the program, so different compiler, they may have different error message. So you can see here the error message that tells you assignment of read-only pointer. So the read-only pointer, they told you the reason is that's a read-only location, but you try to do the assignment. So that's the error came from. Because you cannot assign the value, reassign the value through the read-only pointer. So that's how we need to comment it out. Then you will see, okay, yeah, so then your program can run. So that's the second way we point, using a pointer to refer to the variable. If we want to have the pointer refer to variable is read only, right? So then you will have this const keyword before your data type. So through the pointer, you cannot update the variable. So this example, actually, we see many. Did you remember in your assignment 13, I actually have all the function to passing an array through the pointer. So when you have a show values array, you see you do the constant pointer. That means your array can be passed, but in the show value through the pointer, you cannot update the data. So therefore the searching will be the same. But you can see here, when you do the fill array, I still passing the array, right? Sorting the array, I still passing the array, right? But I don't have the const keyword because for the fill array, I need to update the data, each element in the array. So I cannot passing through the const keyword. I cannot do the read only. I need to be able to write. So that's the same thing as the sort array. So that's before how we're using the constant keyword. We're using through the function, passing function argument. Or you can just have your pointer have the refer to the constant data type. So then I want to show you the other one is we really call the constant pointer. So what is constant pointer? Right, you still have the const keyword, but this const keyword actually is after your data type. Okay, so did you see the constant keyword location is different? If I make the const keyword is after the data type, I make this pointer is a constant pointer. What does mean constant pointer? So constant pointer actually is make this const keyword associated with this PTR. So this PTR becomes the constant pointer. They cannot be reassigned the location. So they will be like this. So the same thing, a constant pointer is a pointer that is initialized with the address and cannot point to anything else. That's mean here, I still have my value variable. Then I declare a constant pointer. So this constant pointer actually is, this const keyword is associated with the pointer. So then make this value can only be assigned one time. So you need to write a way to assign the location. But through the PTR, you still can reassign the value. However, if you want to through the PTR to using, for example, I have another integer value, called value y. So then if I want to reassign this PTR to another location, then you will have compiling error. So that's what we call the constant pointer. So we see what the constant pointer means. So let's add another variable. So constant pointer means I have int pointer. Okay, so this const keyword I associate with my pointer. So that's why we just say CTR. So then I need to write away assign to X. So then from here, you can still using the CPTR to assign the value. so they will be available.